Now, okay, let's see. First thing. Okay, let's see how well we remember. First test question. Maybe not the first test question, but something you might be asked. What is the equation of the quadratic parent function?
Y equals x squared.
Very good. Y equals x squared. Okay, can more than one person say that? What's the quadratic parent function? Y equals x squared. Now, we're going to start with graphing y equals x squared. If you look at the table, okay, so the first thing I want you to do, now you can do this, use it, you could just plug in your x, okay, but what I want to do is just put it into y equals. Somebody grab the door, please.
Door.
Okay. Now put y equals x squared in y sub 1. Okay. And go to the table. Okay, now we go to -3 where x is -3. What's our y? 9. Yes, I know. I just said that just a second ago. But you are correct. Okay. Just hold on. When x equals -2, what's y? 4. When x equals -1, 1. When x equals 0, 0. 1, 4, 9. Okay. Now, okay, when we put these on the graph, okay, now I always start with 0, 0. Okay. Put 0, 0. Then we have 1, 1. 1, -1. 2, 4. Haven't taken roll yet. Doesn't look like
No, I
it.
don't see her.
Nope.
If she appears,
Okay.
would you send her down?
Yes,
please?
ma'am.
Thank you.
Okay, then 2, -4. 3, 9. -3, 9. Oops, that's -4, 9. Oops, bad plot. Okay, there's our graph of our quadratic parent function. Now, what we're going to do with that is we're going to change certain parts of our parent function and see what it does to the graph. Okay, now right here, okay, it says in y sub 1, graph y equals x squared. You can go ahead and just hit the word graph. Okay, should look something like this. Okay, now what I want you to do is just draw a quick sketch. Oops, that's not very good. Of what that looks like. Okay, now it says in y sub 2, graph 2x squared. Now, what changed? What changed between x squared and the next one? Okay, now, what's understood in front of that x squared? 1. Okay, so the number in front of x squared is 1. Okay, so now the number in front of x squared got what? Bigger or smaller? Bigger. The number got bigger. Okay, let's see what it changes on the graph. Okay, that's the second one. What happened? Okay, it got more narrow. Okay, so that's y equals x squared. Okay, so the second one is more narrow. So that's y equals 2x squared. Okay, then in y sub 3, it says put 5x squared. Okay, so the number got even bigger. So what's going to happen to the graph? Okay, once again, it's going to get more. How about let's think of a word. it's getting narrow. Okay? So y equals 5x squared. Okay, so now, okay, right here, our conclusion. As the number in front of x squared gets bigger, the graph gets, this doesn't sound, more narrow. Okay, now, this is sometimes referred to as a vertical, what am I doing? Or if I grab it right here and I stretch it. This is sometimes called a vertical stretch. Okay, so if you take something and you stretch it, it gets more narrow, right? Okay, so that right here, this number is getting bigger. The number in front of x squared is getting bigger. If you look at the next set, what's actually happening to the number in front of the x squared? It's getting smaller. Fractions are smaller. Okay, what's smaller? 1/2 or 1/5? 1/5. Okay, so let's go back to our calculator. Okay, first of all, just go ahead and sketch your y equals x squared.
This is going to be like the worst drawing I've ever seen.
Yours or mine?
Mine.
Oh, okay.
Both.
Both.
And unless you want to say it's bad, then you say it not.
Okay, now clear out your 2 and 3. Okay, and y sub 2, 1 divided by 2, x squared. Now, what do you think is going to happen as the number gets smaller? What's going to happen to the graph? Okay, that's good. Let's look. Okay, 1 divided by 2. Okay, so it got fatter or wider. Okay, so y equals 1/2 x squared. Okay, now, what do we think is going to happen when we put in 1/5 x squared? It's going to get even wider. So we can just go ahead and draw it.
Oh, this is going to be the worst.
Okay, so down here, as the number in front of x squared gets smaller, the graph gets wider. Okay, now this was called a vertical stretch. When I take something and do that, what am I actually doing? If this is a stretch, what's the opposite of a stretch? Anybody know that word? Okay, you might see it before. Okay, this is called a vertical compression. Okay, stretch is more narrow. Compression is, it gets wider. When you compress something, it gets wider. Okay, we good there? Okay, that's one thing we can do to the parent function. Okay, we can make the graph wider, or we can make it more narrow. Okay, when we turn the page. Okay, now we've already kind of talked about this before. Okay, now, okay, what's happening between y sub 1 and y sub 2? What's the number in front of x squared here? What's the number in front of x squared here? -1. So let's see what it does to the graph. This is the easy one. Okay, draw our y equals x squared. Okay, so let's put that. It's already in my calculator, and y sub 2. I'm going to put y equals negative x squared. Okay, and hit graph. There's y equals x squared. Y equals negative x squared. What happened to the graph? Okay, that's correct. We're going to call it two different things. And what else? What else could you say? It goes from the first one opens which direction? Up. The negative makes it open down. Okay, so that's so y equals negative x squared. Okay, so how does y equals x squared change? Okay, you could put positive opens which direction? Up. Negative opens down. Very good. Okay, and another way you could say it, it reflects across what? What is that? Very good. It reflects across x-axis. Okay, that's their two changes so far. First of all, okay, let's just repeat. As the number in front of x squared gets bigger, what happens to the graph? It gets more narrow. Good. As it gets smaller, it gets wider. Okay, positive numbers in front of x squared open which way? Up. Negative open down. Okay, we look at our next set. Okay, what are we doing? We're either adding something or subtracting something. Okay, let's see what happens to the graph. Start with our y equals x squared again. Okay, so now the first one, y equals x squared. Before you graph it, does anybody want to guess to see what happens? What do you think is going to happen? Yes?
I already know.
Oh, yeah.
I think the graph moves up.
Okay, let's see.
Yeah.
Let's see if you're right. Okay, hit graph. Y equals x squared. Y equals x squared plus 5. So was he correct?
Yeah,
Did the graph move up? Now, how far, if you can count those, how far did it move up? 5. Very good. Now, it might look like it here, but did the width change? No. Okay. So go ahead and sketch your y equals x squared plus 5. Okay. Now, what's going to happen on the third one? Yes, sir.
Drop 5.
It's going to go down 5. Very good. Okay, I don't even have to put that in my calculator. It just moves down 5. Okay, so how does x squared change? If you add something to x squared, if you add something, it goes which direction? Okay, it moves up. Okay, if we subtract something, it moves down. Okay, now, we're going to come up with equations. Okay, now, first of all, Okay, to check the width. Okay, can you remember 0, 0, and 1, 1?
Oh,
Can you remember 0, 0, and 1, 1? Yeah, I think you can.
I have
Okay,
it down.
now, okay, 0, 0, and 1, 1. Those are 2 points that are on the parent function. Okay, now, if you look at these, now, I'm not really worried about what the exact fraction right now. We can do that in Algebra 2. But I want you to be able to tell if it got wider or if it got more narrow. Okay? If you can remember 0, 0, and 1, 1, you can tell. Okay? Look at these 4 graphs. Okay? 0, 0. 1, 1. Did the graph get wider or more narrow? It got wider. Okay, so now over here to the side, it got wider. Okay, so now, like I said, I really don't care. I really don't care what the exact fraction or the exact number is right now. I just want to be able to tell that you know the graph got wider. Okay, now, so if we start with our parent function, what was my parent function? Y equals x squared. How do we make that wider? By making the number in front of x squared smaller. What's a number, what can we put in front of x squared to make it smaller? 1/2, okay? So y equals 1/2 x squared. If you put that right now, now this might be 1/3, I don't, okay? Let's say 2. I don't know exactly what it is. I just want to be able to tell that you know how to make the graph wider. Okay, look at the second one. Plot 0, 0, and 1, 1. Did the graph get wider or more narrow? More narrow. So we start with y. How do I make it more narrow? Putting a number in front of x squared. So y equals, that's too little. Okay, I'm just going to say 2x squared. Okay, for right now, that's good enough. Now, we'll look at later, probably next year, how to come up with the exact fraction or whatever. What? Okay, now. Okay, first thing I want to do, now most of these that you'll have, you know, you're not going to have to worry about if it got wider or narrow. Okay, but we can always check. Okay, just start at the vertex. Say that's 0, 0, go left 1, up 1. Did it get wider or more narrow? 0, 0, 1, 1. It's on the graph. Do you see that? Okay, so did the width change? No, the width did not change. What did the graph do? It moved down. How far did it move down? 2. Moves down 2. Okay, now we don't have to change the width. So we start with y equals x squared. How do I move it down to? Minus 2. Okay, now, the last graph did 2 different things. First thing, where is it opening?
Down.
It opens down. Okay, what else changed? It moved up, how far?
2.
Up 2. Okay, very good. So y equals, how do I make it open down? Negative. X squared, how do I move it up 2? Plus 2. Okay, so 3 things. Okay, how do I make it wider?
The number is bigger. Yeah.
Smaller numbers.
Yeah.
Okay, which one? How do I make it bigger? I mean, how do I make it wider? Excuse me. Smaller numbers. How do I make it more narrow? Bigger number. How do I make it open down?
Negative.
Negative. How do I move it up the graph? Add. Add something. How do I move it down? Subtract something. Okay? Now,